Hey, 7th grade. Okay, so your test is Friday for this unit over weathering, erosion, deposition, ecoregions, catastrophic events, and then also human activity on water. So we're going to go over, Friday's exit ticket real quick, and then we're going to get started on today. So Friday's exit ticket was about runoff. And so Friday we talked about how much water we have available here on Earth, and it's very little that we have that's drinkable. And so we're going to talk about we talked about runoff, and that runoff and watersheds affect our water, our drinking water. So a watershed is where the water kind of collects. So we have, hills and valleys. And so when it rains, that water is going to travel from the uphill to the downhill. And where it collects is going to be our watershed. And our watershed is usually going to be either a lake or a stream or the ocean. And so that's usually, except for the ocean, that's usually where we're going to get our drinking water. Like I said, except for the ocean we don't get our drinking water from. But if we have a lake or a river, or an aquifer, that's usually where we get our drinking water from. Now, when it rains and it moves downhill, that's called runoff. And that runoff picks up everything that it is going through and takes it into the lake or the river that we are getting our water from. So our exit ticket from Friday was the picture below models runoff from a mine into local watersheds. The runoff will affect local watersheds in all the following ways except. So you got to pay attention to that except. That except means what is not true. So another way to read this question is what will runoff not do? Okay. So by contaminating the lake with heavy metals, will it do that? Yes, because it's going to run all the stuff from the mine into the lake. So that would be not the answer because it does do that. By increasing sediment in the stream, yes. As the water runs through, it's going to pick up rock and sediment and bring it into the lake. So again, that's a yes, so it's not going to be your answer. We're going to skip to D. By introducing acid rock drainage into the lake and stream. So again, yes, it's going to take the acid rock from the mine and bring it into the lake and into the stream. The only one that does not make sense here is C. It's not going to increase the number of animals that live in this lake or the stream. It's actually going to decrease the number of animals because it's going to kill off some because of the contaminations of the metals, the sediment, and the acid rock are going to kill off some of the animals that live in the lake and the stream. So it's not going to increase, it'll actually decrease the number of animals. So the answer here was C. So today we're going to talk about aquifers, and aquifers are layers of rock and sand and clay that hold groundwater. And so the groundwater is stored underneath in the permeable rock layers. And permeable means that it is able to, the water's able to flow through it. And so if the water's not able to flow through it, we're not going to have an aquifer. Okay, like this clay is impermeable, which means water does not flow through it. And so we can't have an aquifer where water can't go. Okay, so it's got to be permeable, which means that water can get through it. And then the other side of that is that it's got to be porous. And porous means that there is holes inside of the sediment that water collects. Okay, so porous means holes, and permeable means that water can get through it. Okay, so today you guys are going to watch this video of me doing an aquifer in a cup. You can also do it at home if you have the materials. But you should be able to answer 1 and 2 and 3. What is groundwater? What is porosity? And what is permeability? If you didn't catch those definitions, rewind and rewatch the video. Okay, so we're going to look at an aquifer. And we have here, there we go. I have sand. Sand is still permeable because water can get through it, but it's not very porous because it doesn't have a lot of big holes. You can see that there are some holes. You can see that water can get through it, but it's not highly porous because it has small holes. Now, gravel, on the other hand, let's see. As you can see, the gravel here has very large holes, so it's very porous meaning it has a lot of holes that water can get through. It's very porous and it's very permeable because water can get through it easily. Okay, so this right here, this cup, is going to be our aquifer. An aquifer is, like I said, layers of permeable rock and sediment that hold groundwater. So we have a layer of gravel and a layer of sand. So we are going to look at how groundwater is stored. Okay. All right, so we're going to recharge our aquifer by precipitation or rain. Actually, we're going to do it on this side so that you can, so that you can see. So we've got some rain going on. You can see that it's very highly permeable because that water is being absorbed very quickly. I see my water layer here. So, not quite. You can see that the water is being absorbed by the sand, so it is still permeable. And then we have here, okay, so that's, I'm pouring too much water. Okay, so you can kind of see. It's very hard to see, but you can kind of see where the water stops, and where that water stops underneath is called the water table. The water table is just that how much water is being stored, so that top, how much water is being stored in the aquifer. So where that water stops is the water table. So you can kind of see that layer there now, right there. Okay. So water table is where that water stops underneath the ground. I already answered, how's an aquifer get recharged? By precipitation. All right, so we are going to look at a confining layer. And a confining layer is means that there's an impermeable, or water can't get through it, layer. Okay, so a confining layer is an impermeable layer. And so a lot of times that's going to be clay. Clay is impermeable, or sometimes cement, like our streets and parking lots and stuff like that are impermeable. Water doesn't get through it. And so that is going to be considered a confining layer also. So we're going to add a confining layer to half of this cup. I'm going to take some clay. And we're going to add it to about half of our cup so that we have a confining layer and we have a side that doesn't have a confining layer. All right, so now we have a layer of clay. You can see that we have our layer of clay, our layer of sand, our layer of gravel. So now what we're going to do is we're going to talk about human activity. And we talked about that yesterday, or on Friday and Thursday, about how humans affect our water. And our water is affected by our pollution. We litter our oil, our fertilizers, our pesticides from farms. And so when that happens, it may get on a confining layer, and that's fine. It doesn't go through. And then if it gets on, let's say, a permeable layer, it's going to go into our water supply. So this red dye is going to represent our pollution. So if I add some red dye, and then I add some more water, okay, If it rains, it's going to go into our water table and it's going to affect our water supply. Now, if I put this red dye on my confining layer, it's not going to go anywhere. It's going to stay on the top. It's not going to go through it, as you can see. Oh, it's not a good example. Okay. So it's going to stay on top. But if it rains on top of that layer, what happens? It's going to go into the permeable layer here on this side, and it's going to contaminate our water anyways. So yeah, it's a good thing we have impenetrable layers, the confining layer, just so that we have less pollution. But once it rains, that rain is going to pick up the pollution and put it into our water supply anyways. Okay. Then your last thing you need to do on this sheet is to write 3 to 4 sentences about how humans can pollute the groundwater. So using what you saw today, how can we pollute our groundwater? Now, and then you have your exit ticket for today is about watersheds again. This is an aquifer. It says, when an area is experiencing drought, humans may excessively pump groundwater out of the aquifers like this one. All the following are effects of this excessive pumping, except. So what is it not going to do? So if we take all the water out of the aquifer with this well, what is it not going to do? All of these is going to happen except for one, and that one that's not going to happen is your answer. Okay, so if you have any questions, please let me know, and have a great day. Remember, your test is Friday.